Okay, let's just take a quick look at this idea of exponential notation. Um, we've talked about subscripts, so we have, for instance, the mass of the Earth, and that's estimated to be approximately 5.97 times 10 to the 24th kilograms. Now, this is a typical exponential notation type format. And it's very useful because otherwise we'd have to write this out 10, 20, 24. We'd have all these zeros here that we'd have to write out. This is not very efficient. We don't really care too much about all these zeros. We're primarily interested in the 5.97. 10 to the 24th kind of tells us all we need to know about how many zeros are there. So we typically write that then as 5.97 times 10 to the 24th, and don't forget your units. We also, just to use another example, we have the mass of the moon. That's 7.75 approximately, let's say, times I think that's a 7.35 times 10 to the 22nd kilograms. And here we have an example of kind of a division problem. Let's say the mass of the Earth is how many times the mass of the moon. So we're kind of asking this question here. So what is n? How many times the mass of the moon? How many moons does it take to provide the same mass as the mass of the Earth? So what we need to do is we need to divide that n is just going to be equal to the mass of the Earth divided by the mass of the moon. Okay, so and we can make life simple here by noting that 5.97 times 10 to the 24th is equal to 597 times 10 to the 22nd. In other words, we've just kind of moved the decimal place over to here and changed this number to 22. So, and that's basically, if I counted correctly, that's how many zeros we have here. 22 zeros. So we're writing 597 times 10 to the 22nd divided by 7.35 times 10 to the 22nd, and that, let's rewrite that. So you got 22nd over 7.35 times 10 to the 22nd. Now remember when we talked about superscripts, we said that something like x to the a divided by x to the b was equal to x to the a minus b. Well, in this case, we have 10 to the 22nd divided by 10 to the 22nd. So this quantity here basically cancels each other out. The 10 to the 22nds cancel each other out, and let's go ahead and just cross that out. So that we end up with the much simpler notation of 597 divided by 7.35. And I hope you saw my error there. Let's go back and get rid of that. Let's rewrite that as 597. And if you get your calculator out, you'll find that this is approximately equal to 81. So we could say that the mass of the Earth is approximately 81 times the mass of the Moon. And this 81 in that previous equation is our n. Which we just solved for. So let me close that up. So is equal to n. Okay, so that's a pretty simple example of exponential notation. We're going to use that quite a bit, so it'll be useful for you to make sure that you understand that and get familiar with the basic ideas. So another example would be the mass of the crust divided by the volume of the crust. Now, let me ask you to think about what that is first. What is the mass of something divided by the volume of something? It basically just gives you the density. So this would be the density of the crust. And in order to calculate this, we have to be units consistent. So the units, and we often use brackets to represent units. And the units would be kilograms. And generally we have when we're dealing with kilograms, we're using meters as our measurement of length. So we'd have a density of kilograms per cubic meter rather than grams per cubic centimeter.